So hello and welcome back. So I was about to do a couple of example videos, and then I kind of ran into the concept of direct and inverse proportions, and so I thought I would talk a little bit about inverse and direct and inverse proportions, and then once we have done this part, then we will go and do a couple more examples on those linear equations. So basically what I want to talk about now is direct and inverse proportions. Direct and inverse proportions. Direct and inverse proportions. And basically the idea is very simple, but it's very useful in mathematics and in solving problems mathematically. And of course you need to have a clear understanding of basically what direct proportion is, what inverse proportion is, and so on and so forth. So basically a direct proportion is basically what direct proportion is for example, let's say that you want to make some coffee. So in order to make coffee, you need, for example, milk, you need coffee, and you probably need some sugar, right? So suppose that for example, for 1 cup of coffee, you need, for example, 50 ml of milk. You need, for example, 2 teaspoonfuls of sugar, and you probably need, for example, 1 teaspoonful of coffee. Okay, so that's basically, and then of course you need some water. We don't have to add everything to the ingredients, just probably just the milk and the sugar and the coffee. And then if it's, for example, instant coffee, you add some hot water to that and you make a cup of coffee. So now what happens is that, for example, if you want to make, let's suppose that you want to make 5 cups of coffee. You want to make 5 cups of coffee. So in order to make 5 cups of coffee, basically it makes logical sense that if you need 50 ml of milk for 1 cup of coffee, for 5 cups of coffee you need 5 times that, meaning that you need 5 times 50 ml of milk, and you need, for example, 5 times the sugar that you needed for one cup, because you're making 5 cups. So 5 times 2 teaspoonfuls of sugar, for example, and of course you need 5 times 1 teaspoonful of coffee. Okay, so basically you see that the amount that we had here, 1 cup, was increased to 5 cups, meaning that I multiplied by 1 times 5 is equal to 1 times 5 is equal to 5, which is this 5 over here. And then 50 ml was basically translated to 5 times 50, and 2 was translated to basically 5 times 2, and 1 was translated to 5 times 1. So you see that these amounts are basically, first of all, these amounts are as you increase the number of cups of coffee that you're making, the amount of the ingredients that you need is also increasing, meaning that you have, for example, let's take for example, to make this a little simpler so that we can understand better. So for example, for 1 cup of coffee you need for example 50 ml of milk. Now forget about the rest of the ingredients, that not that important right now. For 5 cups, you need 5 times 50. For 10 cups, you need 10 times 50, and so on and so forth. So you see that the number of cups of coffee that you make and the amount of milk that you need for those cups of coffee, they are increasing together, and they're increasing proportionally, meaning that if you take the ratio of, for example, 1 to 50, if the ratio of 1 to 50 is equal to 5 times 50 is equal to 10 over 10 times 50, and so on and so forth. The ratios are basically remaining the same. No matter how much you increase the number of cups of coffee, the ratio of the cups of coffee to the amount of milk that you're using over there is actually constant. It's 1 to 50. Again, here you have 1 to 50. Again, here you have 1 to 50, and so on and so forth. So that's the amount. That's the example of a direct proportion, meaning that these two quantities are proportional. They are changing together, increasing or decreasing together, and they are doing so proportionally. Now, another example of, we talked about direct proportion, and there's of course something called inverse proportion. And inverse proportion is another kind of situation where you have, for example, you have some certain amount of work that has to be done, and it takes, for example, 5 men. It takes 5 men, for example, or let's say 5 people. It takes 5 people to finish the work. In, for example, 10 hours. Okay, so 5 people to finish the work in 10 hours. If you have, instead of 5 people, if you have 10 people, it's not like the previous situation where you basically multiply, for example, this amount by 2. This is 5 times 2, which is equal to 10. So if it was a direct proportion, to get this number over here, the number of hours for 10 people, you would probably say, for example, okay, so here I could write, for example, 10 times 2, which is equal to 20 hours. So that means that if you have 5 people over there, it takes 10 hours to finish the job. And if you have 10 people over there, it's going to take 20 hours, which is of course wrong, meaning that if you have 5 people and if it takes 5 people 10 hours, then if you have basically 10 people, then it's going to take them 10 divided by 2, which is equal to 5 hours. Okay, meaning that here the number of people was basically multiplied by 2, and here the number of hours was divided by 2. So this is called an inverse relationship or inverse proportion. And usually the typical usually the typical example for these kinds of proportions is in mathematics textbooks is basically this typical example of basically some work has to be done, and it takes, for example, 5 men and 3 women to finish the work, and then how basically if we make so and so much and so, I mean, such changes to the number of people, what's going to happen to the amount of work. Now, of course, we are going to see a couple more examples over here, but as a better example as a few more better examples for direct proportion. Let's say that, for example, sugar costs, for example, not $5. I don't know what sugar costs in the US or wherever you live, but in Europe, usually sugar costs around 50 euro cents per 50 euro cents per, or I don't know, 50, 70, 80 cents per half a kilogram or so. So let's say that it costs, for example, $2 per kilogram. And you know that a kilogram is basically 1 kilogram is 2 pounds, give or take, but it's approximately 2 pounds. So if sugar costs $2 per kilogram, I would use pound over here, but I'm not very familiar with pound, so I usually don't use it unless I were doing some physics problem or I don't know, chemistry problem. Otherwise, I'm more familiar with kilograms and with kilograms basically. Okay, so if sugar costs, for example, $2 per kilogram, then you can have a table of basically the weight of the sugar, the possible weights of the sugar in kilogram, and the cost of the sugar for that amount of sugar. And you see over here in dollars, and you see over here that, for example, if you have, for example, 1 kilogram of sugar, it's going to cost you $2. If you have, for example, 2 kilograms, 2 times 2 is equal to $4. If you have 3 kilograms, 3 times 2 is equal to $6. 4 kilograms, $8, and so on and so forth. So you see that over here again, this is an example of direct proportion. Okay, of direct proportion. And you see, as the weight is increasing, so is the cost of the sugar. 1, 2, 3, 4, 2, 4, 6, 8, and so on and so forth. They are increasing together, and basically the ratio is actually remaining the same, meaning that over here you see the ratio of weight to cost of the sugar is over here 1 to 2, over here is 2 to 4, over here is 3 to 6, and it's all equal to 1 to 2, 1 to 2, and so on and so forth. The ratio is not changing. So that's basically one example here. Now you can basically, in order to have a better understanding, have a better mathematical understanding of this concept of direct proportion, you can take, for example, one of these variables as, for example, x, and one of these variables you can take it as y. And basically this and if you denote the weight of the sugar as x and then the cost of the sugar as y, then you can basically then you can denote this entry by, for example, x1, x2, x3 and x4 and so on and so forth. And then you can denote this this entry as y1, for example, y2, y3, y4 and so on and so forth. Okay, so x1, x2, x3 and x4. Okay, now you see that over here, so you can see that basically x1 to x2 is equal to x1 to y1 is equal to x2 to y2 is equal to x3 to y3, all the way up to x of n to y of n. And so you can say that basically the ratio of basically x to y of x to y is constant, does not change. And since it's a constant, you can of course say that x to y is equal to some constant k, and then of course then you can rewrite this as, for example, x is equal to y times k, or k times y, or of course you can say x is equal to k times y, where y is basically some constant. And so if there is this kind of relationship between two variables, x is equal to k times y, or if x to y is equal to k, we call this an instance of direct proportion. Direct proportion. Okay, so, and one thing which is interesting here is that which is interesting here is that basically is that basically if you multiply this entry, for example, by 2, you are multiplying this basically x1. If you write x1 times 2 is equal to x2, then the same relationship exists between y1 and y2. Then y1 is also times 2 is going to be equal to y2. So that relationship is also between these pairs of basically entries. And so basically in short, you can write x1 to y1 is equal to x2 to y2, and so on and so forth. Now let me see if there is anything that I can add. Okay, so now as opposed to basically the idea of direct proportion, where basically two variables are basically changing together proportionally, you can see all kinds of phenomena around you that are not basically proportional. For example, let's say my present age is basically, for example, my present age is 40 years old, right? I'm 40 years old right now. So if I had a child, which I don't, if I had a child, my child would be, so this is me and this is my child, okay, and this is my present age. Let's say that I had a child right now, and the child was, for example, I don't know, 20 years old or 15 years old, okay. So my age basically 5 years ago, was basically 35, and my child's age basically 5 years ago would be 10 years. And you see that my age after 5 years is going to be 45, and my child after 5 years would be 20 years old, right? So now you see that over here, if you take this as if you take this as x and y, okay, so this proportion over here, x to y, you see that this is 35 to 10. Here you have 40 to 15, which is equal to so this is something about 3.5, okay, the proportion or the ratio. Here you have divide by 5, you'll get 3, divide by 5, you'll get 8, so 8/3, which is something about 0.6, so that's 8/3, and 8/3 is something about 2.7, which is about 2.7, and 45 to 20 is basically divided by 5, you'll get 9, divided by 5, you'll get 4, so 9/4 is the same thing as 2 point something. 9/4 is the same thing as 2.25. Is the same thing as, is equal to 9/4, which is equal to 2.25. So you see that these two, basically these two amounts or these two variables are changing together. My age and my child's age are changing together, but they're not changing proportionally. So this is no direct proportion. This is not an example of direct proportion, because you see over here, for example, x1 to x2 is 3.5. Here x1 to x2 is 2.7. Here x1 to x2 is equal to 2.25. So age is, for example, one of those things that if you take it between two different people, then it doesn't change proportionally. It changes with time, of course, but not proportionally. I'm sorry, I'm right, meaning that not in direct proportion. So now let me pick a couple of examples here to show us how, basically, a couple of good examples I pick over here. Okay, so one thing which is basically important here is that here you saw that we said that basically if in the example of in the sugar example that we had, we said that, for example, if sugar costs, for example, $2 per kilogram, then if you have the weight over here, and if you have the cost over here in dollars, and that's in kilogram, then basically what you have is that, for example, if you have 1 kilogram, it's going to cost you $2, 2 kilograms $4, and 3 kilograms is going to cost you $6, and so on and so forth. Okay, so if I take this as x and if I take this as y, you see that basically, and that would be x1, for example, x2, x3, and so forth, and so on. Then that would be y1, for example, y2, y3, and so on. Then you can see, we saw that basically x1 to y1 is equal to x2 to y2 is equal to x3 to y3 is equal to all the way up to x of n to y of n. And that's basically an example of, and these are all 1 by 2, 1 by 2, 1 by 2, and so on and so forth. So that's an example of direct proportion. Okay, direct proportion. Okay. Now, so basically you can say that in the case of direct proportion, basically x1 to y1 is the same thing as x2 to y2. Okay. Now this becomes meaningful in the situation that you're working with basically direct proportions. For example, let's say that a train, for example, is moving at a uniform speed of for example 75 kilometers per hour. Okay, so if that's the case, then basically your distance traveled is going to be, if I tabulate the distance traveled versus, for example, time, the distance traveled versus, for example, time elapsed. I don't know if elapsed is written with one L or two L's. Elapse. No, it's one L. Okay. So with time elapsed would be, so distance traveled would be in kilometer, and time elapsed in hours if I take it. Then after 75 kilometers per hour, that means that after 1 hour you will have gone basically 75 kilometers. After 2 hours you will have gone basically 2 times 75, which is equal to 150. After 3 hours you will have gone basically 3 times, that would be 210, and then 15, so 225, and so on and so forth. Okay, so now in this situation, if I take the distance traveled as x, for example, and take this as y, then this relationship of course exists between these pairs of data that I have, if I may call them pairs of data, meaning that then this becomes x1, for example, x2, y1, and y2. And over here you can see that, for example, x1 to y1 is actually equal to x2 to y2, meaning that 75 to 1, the ratio is the same as 150 to 2. 150 to 2 is equal to 75, and 75 to 1 is equal to 75. So basically this relationship exists between between your x and y, whatever you want to call it. And so that's something that you can use in the case of direct proportion to basically calculate things over here. For example, let's say that in this train example over here, let's say that this is, for example, x3 and this is y3, for example. Now suppose that I did not know that this value over here. Suppose that I did not know this value over here. So this is y2. So if basically I know my x1, x2, y1, and I don't know what y2 is, I can write basically x1 to y1 is equal to x2 to y2, x2 to y2, and that's 75 to 1 is equal to 150 to y2, 150 to y2, and if you cross multiply here, you will get 75 times y2 is the same thing as 150, so y2 is equal to, for example, 150 divided by 75, which is equal to 2, and that's basically 2 over here. So that's basically what you can do with this kind of formula, if you may call it a formula, and moreover, you can express it in a different way as well, meaning that you can write this as x1 to y1 is the same thing as x2 to y2. Sometimes it's expressed as so you can divide, basically you can cross multiply here, so that would be x1 y2 is equal to x2 y1, and then divide both sides of this equation by x2, for example. So x1 y2 divided by x2 is equal to x2 y1 divided by x2, and these two will cancel out, and then you can divide both sides of this equation by y1. So you have x1 y2 times x1 y2 times x2 y1, and if I divide both sides of this equation by x2, these two will cancel out. Now I have x2 x1 times y2 divided by x2, that's equal to y1. Okay, now if I divide both sides of this equation by y2, meaning that if I write x1 times y2 divided by x2 and divide by y2 as well, and over here write y1 divided by y2, these two will cancel out, and so this will give me x1 by x2 is equal to y1 by y2, which is basically the same thing that we had before. X1 to y1 is equal to x2 to y2. So these two you can use interchangeably. They're really the same relationship. So that's basically an example. I mean, the whole idea behind basically direct proportion. Okay, now let's go and see a little bit about inverse proportion as well. So, but before I do that, I'll take a few minutes rest and I'll tell you a little bit about inverse proportion as well. Okay, so now about inverse proportion, the good example that we can have is probably that is not very let's take the example of speed versus time taken. For example, time taken for a trip. So let's say that you want to take a trip, and let's say that the distance that you want to travel, so the distance that you want to travel is basically, distance to travel is, for example, I don't know, 10 kilometers. Okay, so basically if basically the distance that you want to travel is 10 kilometers, then depending on the different speeds that you might have, it's going to take you different amounts of time to basically take the same, to travel the same distance. Meaning that if you go, for example, 10 kilometers per hour, it's going to, at this speed, it's going to take you, for example, it's going to take you 1 hour to it's going to take you 1 hour to travel a distance of 10 kilometers. If your speed is, for example, 20 kilometers per hour, so then of course it's going to take you basically half an hour, half an hour in order to travel a distance of 10 kilometers, because your speed is 20 kilometers per hour. If your speed is 30 kilometers per hour, it's going to take you 1/3 of an hour to travel a distance of 10 kilometers. And just to make sure that I haven't made any mistakes, I'm going to check this. So 10 kilometers per hour. So you know that speed is the same thing as distance to time. So for example, if your speed is 10 kilometers, it's going to be 10 kilometers to 1 hour, and 20 would be 10 kilometers to basically 1/2, and 30 would be 10 kilometers to 1/3, which is equal to 30. Okay, so now if you basically do a table of this thing over here, you will have speed, for example, in kilometers per hour, and this is time, for example, taken in hours, and so basically over here we're talking about the same distance, 10 kilometers. So when your speed is 10 kilometers per hour, it's going to take you 1 hour to travel a distance of 10 kilometers. When your speed is 20 kilometers per hour, it's going to take you basically 1/2 hour. It's going to take you 1/2 hour in order to travel the same distance. When your speed is 30 kilometers per hour, it's going to take you 1/3 hours in order to basically travel the same distance. And so what that means is that, so this is to travel 10 kilometers. Okay, so what that means is that, you see, as you're increasing your basically your speed, the time taken in order to travel the same distance is decreasing, and they're one of them is increasing, one of them is decreasing, and they're decreasing, and they are proportional, meaning that 10 to 1 is the same thing as 20 to 1/2. So 20 to 1/2 is the same thing as I think there is a proportion. There has to be a proportion over here, but the proportion is different than the direct relation, than the direct proportion. The inverse, in the case of an inverse proportion, it's basically that proportion kind of disappears, meaning that, for example, 10 to 1 over here is equal to 10, but 20 divided by half is the same thing as 20 divided to 20 times 3, which is equal to 40, or 30 divided by 1/3 is equal to 30 times 3, which is equal to 90. So this kind of relationship which we had before in the case of direct proportion, where we said, for example, if I take this as x and if I take this as y, then this is x1, y1, x2, y2, and x3, y3, and so on and so forth. So it's not like, for example, x1 to y1 is equal to x2 to y2, and so on and so forth. That doesn't exist anymore. But here, basically what happens is that if you multiply, for example, 10 by 2, if you multiply 10 by 2, you are multiplying this by 1/2. Over here you see you're multiplying this by 1/2. Or here, when you multiply this by 3, you're multiplying this by 1/3. Okay, so times 3 times 1/3, and so on and so forth. So that's the kind of relationship that we have here. And so let me see what sort of relationship we have here. Okay, so basically what happens here is that in the case of basically inverse proportion, in the case of inverse proportion, basically what happens is that you see over here, as I am basically the ratio over here, basically you take this number, for example 10, and multiply it by 2, but then you take this number and you have to divide it by 2 or multiply it by 1/2 to get to the next number. So what that means is that basically the ratio of these two numbers, for example 10 to 20, is the same thing as basically 1/2 to 1. 1/2 to 1. Meaning that 10 to 20 is equal to 1 to basically 2, and then 1/2 to 1 is equal to 1 to 2, so 1/2 is equal to 1/2. Or the relationship between that you can see over here is, for example, 20 to 30. 20 to 30, and then that's equal to 1/3 to basically 1/3 to 1/2. 1/3 to 1/2. So 20 to 30 is the same thing as 2 to 3. And 1/3 to 1/2 is the same thing as, so 1/3 to 1/2 is the same thing as 1/3 times 2, which is equal to 2/3. And so this whole thing is 2/3, so 2/3 is equal to 2/3. So then you can say that x2, for example, to x3, x2 to x3 over here is the same thing as not y2 to y3. So in the case of a direct proportion, I would write this as x2 to x3 is the same thing as y2 to y3. But since this is an inverse proportion, then you can say that, as you can see, as you saw over here, the ratio of these two numbers, 20 to 30, for example, the ratio of these two was equal to 1/3 to 1/2. 1/3 to 1/2. So you can say that x2 to x3 is the same thing as y3 to y2. y3 to y2. So that's basically called inverse proportion. Okay. So now what that means is that, of course, you can cross multiply, and but before we go any further, what I want to do here is that I want to give you a couple of definitions here before we move any further. So the definition is that basically in the case of direct proportion, we said that two quantities or two variables, we say that they are in direct proportion. In direct proportion, if basically x and y being the two different variables, the ratio of these two numbers is equal to k. So you can basically write x is equal to ky, for example, k being a constant. Okay, but in the case of these proportions, we say that basically two variables, you could call them, are in reverse proportion. If basically over here you see that if you divide this number by this number, that it remains proportional. But in the case of reverse proportion, you see that 10 times 1 is the same thing as 20 times 1/2, or it is the same thing as 30 times 1/3. So the product of those two numbers remains constant. So that means that x times y is the same thing as k. And that makes sense because, for example, in the case of this situation of speed over here, as we increase our speed, the time is decreasing. So speed is increasing and the time is decreasing, and they have to basically remain proportionate. Otherwise, basically physics could not exist the way that it is. So and based on that proportion, we have, for example, the speed is equal to basically distance divided by time. Or you can say that basically you say that s is equal to d by t, or st is equal to d, or basically, now if you take the product of speed and time, that would be d, and you see that basically speed times time is always equal to distance, which is basically which acts as something like a constant over here. So as we saw in the case of this example over here, as basically we were changing the speed over here, the time was changing, and the product of these two numbers remained constant, meaning that we had, for example, 10 times 1 is equal to 10, 20 times half is equal to 10, 30 times 1/3 is equal to 10. So the product of these two numbers, x1, y1, x2, y2, x3, y3, is remaining constant. It's not basically changing. And this kind of relationship, we call it reverse proportion. So basically we call it x times y is equal to k. And you saw that over here, basically the ratio of these two numbers, x1 to x2, was equal to basically y2 to y1. Okay, so that's basically the whole story here. So from the reverse proportion, if you learn this much, then of course you will be able to solve all kinds of logical problems involving this kind of proportion. So that's basically kind of the whole story here. And basically one more thing which is also important is that when two quantities, for example x and y, are in direct proportion, okay, then we write that x is proportional to y. We write it this way: x is proportional to y. If x and y are in basically inverse proportion, in inverse proportion, we write that x is proportionate to the reciprocal of y. That's basically how we write this. So that's something that you might be interested in. So now let's do an example over here. Let's do a couple of examples to see how this whole thing goes. Okay, so as an example, let's say that you have a tank. You have a tank over here, and you want to fill it with some pipes. Okay, so you have some pipes over here, all are connected to some source, for example, and water is coming in here, and water basically goes in here, and you want to basically fill your tank this way. Now suppose that you have, basically if you have 6 pipes, it takes basically 1 hour and 20 minutes, 1 hour and 20 minutes to fill this tank. Now what you want to know is that how long is it going to take? How long is it going to take if you had only 5 pipes? If you had only 5 pipes, how long would it take in order to fill the same tank? So in order to solve this problem, first of all, what you can do it systematically, or if you understand basically inverse proportion, then you can do it very simply as well. Meaning that, for example, in order to get from 6 to 5, I mean, if you don't want to do it systematically, just solve the problem. In order to get from 6 to 5, you have to multiply this number by something. So 6 times some x is equal to 5. And so x is equal to 5/6. So if I multiply my 6 by 5/6, I'm going to get to 5, right? So what I'm going to do is that since it's a case of inverse proportion, meaning that I mean, originally you had 6 pipes, and with 6 pipes it's going to take you 1 hour and 20 minutes in order to fill this tank, right? Now if the number of pipes is reduced or decreased, the time taken to fill the same tank is going to increase as well. So by decreasing this, then this amount is going to increase. So it's inverse. It's an example of inverse proportion. So since it's an inverse proportion, now here I'm multiplying by 5/6. So here, if I multiply by the inverse of this, which is 6/5, if I multiply 1 hour 20 minutes by 6/5, I'm going to get the time over here. So 1 hour 20 minutes is the same thing as 80 minutes, right? So that's 60 plus 20 is equal to 80 minutes. And 80 times 6/5 is the same thing as 40. So 5 times 8 is equal to 40, right? So that's 40 times 2, and that's 5 times 8 times 2. So 5 and 5 you can cancel out, and then that's 16 times 6. That's 16 times 6, so 36, 96 minutes. It's going to take 96 minutes. Meaning that it's about 1 hour and basically 36 minutes. So it was 1 hour 20 minutes. Now it's increased to 1 hour 36 minutes. So that's basically how you solve this problem. And remember that, for example, let's say that in the case of this was a case of an inverse proportion. Let me give you an example before I go to the next way of solving the same problem. Let me give you an example so that you can basically compare direct inverse proportion and direct proportion. So let's say that you have, for example, 1 kilogram of sugar is going to cost you, for example, $2. Right? 1 kilogram of sugar is going to cost you $2. Now, for example, 2 kilogram of sugar is going to cost you what? So this is the case of direct proportion, because when you buy 1 kilogram of sugar and it costs you $2, the more sugar that you have, the more you have to pay. So that's direct proportion, right? So if that's direct proportion, now if I multiply my 1 by 2, I have a 1 over here multiplied by 2, I get to 2. So over here, if I multiply this number by the same number as well, times 2, I get to the number that I need here. So 2 times 2 is equal to 4. So then 2 kilograms of sugar is going to cost me $4, when 1 kilogram cost me $2. But as you saw over here basically I multiplied 6 by 5, 6 to get to this number over here, 5. But then over here I multiplied this number by the reciprocal of this number. Over here I multiplied by 5, 6. Over here I had to multiply by the reciprocal of this, which is 6/5, right? So that means that I actually divided by that means that here I actually divided by 5/6. When you divide by 5/6, that's the same thing as multiplying by the reciprocal of this number. So that's basically that. And now the right way of solving this problem is basically we said that we have 6 pipes over here, and basically it's going to take 1 hour and 20 minutes or 80 minutes to fill a tank with 6 pipes. If I had 5 pipes, how long would it take? So then you can have a table over here like this, and here you have the number of pipes, and here basically you have, for example, time taken to fill the tank in, for example, in minutes. This is in the number of pipes doesn't really have any units. So when you have 6 pipes over here, it's going to take you 80 minutes. Now when you have 5 pipes over here, how long is it going to take you? And remember that it's an inverse relationship, inverse proportion. So since it's an inverse proportion, what you want to do is that we said that the product of these numbers would remain the same, meaning that x times y, if you take this as x and if you take this as y, since it's an inverse proportion, x times y remains basically the same and remains constant, equal to k. And so of course you can basically meaning that if it's constant, then for example, if you multiply these two numbers together, it's going to be equal to the product of these two numbers, the product of next two numbers, and so on and so forth. So if this was, for example, x1 y1 and x2 y2, for example, then x1 y1 would be equal to x2 y2. Okay, and so what that means is that basically, if you divide, for example, both sides of this equation by x2, x1 y1 by x2 is equal to x2 y2 by x2, and these two would cancel out. You have x1 y1 by x2 is equal to y2. Okay, and then you have here, what you have is, if I divide by y1, x1 y1 by x2, and divide by y1 as well, so y2 to y1, these two would cancel out, and then you will have x1 to x2 is the same thing as y1 to y1, I'm sorry. So you can use this relationship in order to calculate your stuff in inverse proportion. So this is inverse proportion. Okay, but in the case of direct proportion, it's like this: x1 to x2 is the same thing as y1 to y2. This is direct proportion. This is direct proportion. Okay, so that's basically the whole story. And anytime you forget this kind of thing, you can always find out what these relationships are based on the fact that in the case of an inverse proportion, the product of these two numbers is constant, whereas in the case of direct proportion, the ratio of these two numbers are always constant. So it's always easy to find out what these relationships are, because if you don't use them too often, chances are that you might actually forget them. So now I'm going to use this relationship over here. I'm going to erase all of these things. I don't need them right now. And I'm going to use this relationship to find out what this thing actually is. So we said that basically x1 to x2, which is 6 to 5, is the same thing as y2 to y1. So x2 y1, which is equal to x to AD. I'm sorry, x to AD. So if you cross multiply here, 5x is equal to 6 times 80, and x is equal to 6 times 80 times over 5. And so this is 10 times 8, I'm sorry, 40 times 2, 40 times 2, and this is 5 times 8. So you can, again, you'll end up with 16 times 6. 8 times 2 is equal to 16 times 6 is equal to 96 minutes. And here x is equal to 96 minutes for 5 pipes. Okay, so that's basically what this whole thing is about. Now you can of course have a whole lot of examples about this whole concept, but I guess it's enough for just for the concept. If you have any problems with direct and inverse proportion, you can ask. I mean, if you have any specific questions, you can ask. I'd be happy to answer them if I could. Okay. So in the next video, we are going to get back to those linear equations. There are a few examples that I wanted to discuss, but I needed this concept of in direct and inverse proportion. So we'll go back there, solve a couple of problems, and then I think we're done with that concept as well. So I'll see you in the next video. Thank you.